some variety in terms of convention. In this case of sum, again we talk about your couple circuits. We already spoke about couple circuits about the points. Either it can be, the inductor can be in vertical place, either it can be in horizontal. We already saw one sum in which the inductor was in vertical and one sum in which the inductor was in horizontal case. In this case, my dear friend, you have the inductor placed in horizontal. If it is in horizontal, there are only 4 cases. Let's revise it once again. First, either both the coupling will be on right. Second, both the coupling will be on left. Third, both the coupling will be on left or right or left. So if it is on right, both left, it is replaced by a voltage source. Left right, right left, again by a voltage source. Then what is the difference? The difference is in sign convention. If both are right, both are left, sign convention will be plus minus. If one is right, if one is left, or one is left, one is right, in that case the sign convention will be minus plus. So let's read out the circuit by replacing the dot convention by a voltage source. So in this case, you have a sinusoidal voltage source plus minus 50 angle 0. Replace it by a voltage source in series with the inductor, resistance 3 ohms, minus J4 ohms, J5 ohm. It's your first mesh. Second, again replace it by voltage source. Either you place a voltage source in front of inductor, in back of inductor, doesn't matter because both are in series. Finance. This will be J 10 ohms. Since the combination was one was on left, one was on right, the combination was minus plus. Now next logic arises, what is the value for the voltage source? The value for the voltage source should always be given in the question, either in 2 forms. Either the value will be given in terms of M, so you can directly use it. Either the value will be given in terms of K. Since in this case the value is given as K, so you need to find the value of M. When it is given in K, the value M is equal to K under root L1 L2. You have the value for K, you have the value for inductor, that is 5, you have the value for inductor L2, that is your value of stand. So put the value, you will get the value for M, that is K will be 0.8 under root, this will be 5 into 10. Simplify it, my dear friends, you will get the value of M, that is nothing but simplify by using a calculator, com mode, this will be 0.8 into root bracket, since there are 2 terms, 5 into 10 bracket close, so the value which you get is 5.65. So that is the value for your voltage source. So your voltage source is always written in imaginary form, so it is given as J 5.65. Again over here it's written as J 5.65. So what is the difference? Since both the sign convention is same, both are voltage source, both the value is same, then what is the difference? The difference comes in terms of current source. When I say, my dear friends, it is mutually coupling, that means this point depend on this point. When I say this point depend on this point, which current is flowing in this point? You will say it I2. So over here you will get I2. When I say this point is depending on this point, which current flows in this point? You will say I1. So this will be I1. So your final mesh equation will be this. So over here you have 2 mesh, apply 2 currents. Let's do it. In this circuit, ultimately it's given, the question given to you is find currents through capacitor. So when I say find the current through capacitor, that means my capacitor is minus J4. So my capacitor is lying in between, that means both the current are flowing. So at the end I need to find I1 as well as I2. Unless and until I don't find I1, I2, I won't be getting current across capacitor. So let's do it. We'll apply KVL in the above equation. I hope you have drawn this network in your book, so it will be much easier for you to understand the further process, because this diagram won't be repeated in the further process. Okay, so let's write the equation for KVL. So the equation will be applying KVL in mesh 1, we get the equation will be add all the terms real as well as imaginary from mesh 1. So the equation will be, my dear friends, in this case it will be 3 plus J5 minus J4. The current flowing is I. So now you'll observe among these terms, is there any other current flowing? You will say yes, I2. So your sign will be negative. Which term? So 3 minus J4, that is nothing but I2, equal to. When I write equal to, on equal to there should be only voltage source. So when I observe carefully in mesh 1, there are two voltage sources. So your current enters into negative, it will be positive. Your current enters into negative, it will be positive. So 5.65. Since we have a straightforward rule on RHS, there should be only numbers. All the variables, my dear friend, should be shifted on LHS side. So let's shift all the variables. So the term which you will be getting is 3 plus J1 I1 minus 3 minus J4 I2. So it will be minus J 5.65 I2 equal to, it will be angle 50 0. So simplified, this is 3 plus J1 I1 minus 3 minus J4. Take this in terms of bracket. Since there is a minus sign outside, the sign will change. The sign is negative, so it will be positive. So your term will be I2. This will be 50 angle 0. So rewrite the equation and simplify it. 3 angle J1 minus, in fact 3 plus J1. So minus J4 plus, this will be 3 plus J 1.65. This will be I2. This will be 50 angle 0. This will be equation number. Since basic law, if you have two unknowns, you need to have two equations. So now the second you will be applying in your mesh 2, my dear friends. So let's apply. So logic will be applying KVL in mesh 2, we get. In mesh 2, let's add all the terms. When you add all the terms, my dear friends, you will be getting 8 plus J10 minus J4 I2. Since I've taken mesh 2, so I2 will be positive. Apart from this, take for I1, so this will be 3 minus J4, that will be I1, the sign will be negative. This will be equal. On equal to, there should be only voltages. If you observe carefully in mesh 2, there is only one voltage. So when your current enters into negative, it will be positive. This will be J 5.65, it will be I1. Rule says on equal to, there should be only numbers, no variables. So if we shift the variable this side, so your term will be minus 3 minus J4 I1 minus J 5.65 I1 plus, this will be 8 plus J 6 I2 equal to 0. So your term will be minus, since there is negative outside, the sign will change. So this will be 3 minus J4 plus J 5.65 I1 plus 8 plus J6. This will be I2 equal to 0. So on next page you will simplify the equation number B. So your final equation for B, which you will get, my dear friend, will be minus 3 plus J 1.65 I1 plus 8 plus J6. This will be I2 equal to 0. That will be equation number B. So after getting two unknowns, now we need to find the current of I1 and I2. The I1 and I2 current which we'll be getting by using calculator. After getting two equations, the question says I need to find the current across capacitor. If you have the network in your book, you will carefully observe in your capacitor you will be having both the currents, I1 as well as I2. So let's do it from I1. So for I1, we'll be drawing 2 by 2 matrix because you have two equations. For I1 and I2, your denominator will be remain the same. Only the change will be in numerator. So let's look very carefully for I1. If I need to find I1, this is my column for I1, this is my column for I2. If I need to find I1, my column of I1 should be replaced by RHS of both the equation. My column of I1 should be replaced by RHS of both the equation. So my RHS for first equation was 50 angle 0, second was 0. This will be the coefficient for I2 for both the equation. First equation over here and second equation. First equation, if I observe carefully, my coefficient for I2 was minus bracket 3 plus j 1.65, and for second equation is 8 plus j6. In denominator, you only need to write the coefficient of I1 and I2. That's it. That's the reason I said for finding I1 and for finding I2, your denominator part is same. Only change will be in terms of numerator. So in first equation, which you got is 3 plus j1, coefficient of I1, I2, this will be minus 3 plus j 1.65. In second equation, coefficient of I1 is minus 3 plus j 1.65. This will be 8 plus j6. Simplify it by using a scientific calculator. So you'll be getting, in this case, will be, since you have j term, so you need to use in complex form. So let's simplify only numerator, then denominator, then divide both the term. So it will be a bracket. This bracket will be only for numerator, which you will be closing at the end. So let's give every term a bracket. So you multiply this with this. So bracket 50, angle will be shift and fourth button 0, bracket close, again bracket, this term 8 plus. So while writing calculator, you write I. So this will be after the number. It will be 6 I, bracket close, minus sign. Again bracket. If you multiply with this, you will get 0 directly. Bracket close for numerator equal to. The value which you got is 400. The imaginary value is shift and equal to, that is plus j 300 whole upon. Let's simplify the denominator, my dear friends. Bracket. This bracket is for denominator. So now put a bracket for each and every term. You multiply this with this term. So bracket is 3 plus 1 I, bracket close. Bracket, this will be 8 plus 6 I, bracket close, minus bracket, minus minus plus, so it is gone. It will be 3 plus 1.65 I, bracket close, bracket, it will be 3 plus 1.65 I, bracket close, again bracket close for denominator. So value which you get is 11.72, shift n equal to, the value which you get over here is j 16.1. So divide both the value, you will get the value for I1. So let's divide bracket numerator value 400 plus 300 I, bracket close, divide by bracket 11.72 plus 16.1 I, bracket close. So the value which you get is 24. Shift n equal to, the value which you will be getting, my dear friend, is minus j 7.37 amperes. The value which you got is in your rectangular form. So it's your choice. If you want to convert into polar, you can, but that is not compulsion. So let's convert into polar. Let's have a knowledge of polar as well, which we have already done it in previous time. So this is a rectangular form. If I need to convert into polar, what is the procedure? You have to be in complex form, right? So the value which you got, my dear friend, is 24 minus 7.37 I shift and plus sign for polar. So you'll get R and theta. So the value for R which you get is 25.10 angle shift and equal to the value angle which you get is minus 17.07 amperes. That's the value for I1 which you're getting it. So now let's solve the same procedure for I2. So this will be again using the same about two equations. Let's go for I2. Two unknowns, 2 by 2 equation. The denominator part will be the coefficient of I1 and I2. That's the reason I said in I1 and I2 the denominator won't change. Only change will be in numerator. If I need to find I2, my dear friend, so I need to observe the column of I2. The column of I2 is replaced by its RHS. So in first case, if I observe carefully, my RHS is 50 angle 0. In second case, my RHS is 0. Rest all the values which you need to fill it is just the coefficient value of I1 and I2. So let's fill the values. And first, we just need to find the coefficient of I1 in first equation, that is 3 plus J1. And second, my dear friend, the coefficient which you got is minus 3 plus J 1.65. So let's write the coefficient of I1 and I2 over here for both the equation. For equation number 1, my dear friend, the value which you got is 3 plus J1. For I2 coefficient is in first equation is 3 plus J 1.65. In second equation, the coefficient of I1 was minus 3 plus J 1.65 and the coefficient for I2 was 8 plus J6. Now, by using a calculator, my dear friend, simplify the term. Let's simplify independently. Mode, complex mode, bracket, numerator. Let's simplify bracket. If you multiply this with this, you'll get value 0, bracket close, minus, bracket. This was this. So you'll get 50 angle 0, bracket close, bracket. You have a minus and outside to write minus 1, bracket. This is 3 plus 1.65 I, bracket close, the whole bracket close for numerator. So the answer which you get is 150. And the imaginary part, if you need to get it, so you have to press shift and equal to the value which you get. So it will be plus J 82.5. Again, let's solve the denominator, my dear friends. For denominator, you have to multiply these two terms, bracket for denominator, bracket for each and every term. So it will be 3 plus 1I, bracket close, bracket 8 plus 6I, bracket close, minus sign, again bracket, minus minus plus. So the term will be 3 plus 1.65I, bracket. This will be again 3 plus 1.65I, bracket close, whole bracket close. The value which you get is 172. Again shift and equal to, this will be plus J 16.1. So if I need to find I2, my dear friends, I need to divide the numerator and denominator. So let's divide it, bracket. So it will be 150 plus 82.5 I, bracket close, divide by, this will be 172 plus 16.1 I, bracket close. So by the value which you get is 7.78, that is minus J 3.65 amperes. This is nothing but your rectangular form. If I need to convert into polar form, my dear friend, the logic says it should be in complex mode. 7 plus 78 minus 3.65 I, press shift and plus sign. So you'll be converted into 8.59, shift and equal to, your angle is minus 25.13 amperes. So after getting I1 and I2, that was not the logic. The logic was find the current across the capacitor. If you observe the first sum, my dear friend, the value for capacitor was very, very important. Value of capacitor says, in my capacitor, both the current flows. When I say both the current flows, that means I need to check with I1 and I2. So after finding I1 and I2, the ultimately question was find the current across 5 ohms. So the logic was, the formula is I into R. When I say I, my dear friend, my I means I2. When I say R, my R is nothing but your 5 ohms. So put the value of I2 in this case, so you'll get, my dear friend, 8.59 angle minus 25.13 into 5. Simplify it, you'll get the value across 5 ohms. It should be complex mode, bracket, it's 8.59, my dear friend, angle minus 25.13, bracket close, bracket 5, bracket close. So value which you get is 38.88. This is minus 18.23. This is the value for 5 ohms. If I need to convert into polar, so we can convert this value into polar. So it will be 38.88 minus 18.23. I shift n plus sign. The value which you get for R is 42.94. Angle shift n equal to, which you got is minus 2512 volts. So that's the value for voltage across 5 ohms. That's what we wanted from this sum. So let's have few more examples, in this case of a dot convention. Signing off. Thank you.